Hello student, welcome once again to our mathematics standard 8 chapter number 7 cubes and cube roots. So students, there are two exercises 7.1 and 7.2. Here are the questions of exercise 7.1. Look at the question number 1. Which of the following numbers are not perfect cubes? There are 1 to 5 questions. See the answer 216. Students, here we have to follow the prime factorization method. You should have to know about the divisibility test for 2, 3, 5, 7. Okay. So you can get it answer very fast. So 216 is a even number. It should be divided with the 2. So we divide with 2, it will get the 108. 108 again is a even number, divided by 2, which gives me 54. 54 also is a even number, that also is divided by 2. Now it's a 27. Yes, my dear student, 27 is not a even number. It will not divide with the 2. So next prime number is 3. 3 means, what is the rule for 3 divisibility test? Add the all digits and check that number is divisible by 3 or not. So 2 plus 7, 9. Yes, 9 is divisible by 3. So that's why 3 will be possible. 27 by 3, which gives me a 9. And again 9 divided by 3, which gives me a 3. And 3 divided by 3. And at last I got the 1. Now write down this all the numbers in a proper multiplications way. Yes, prime factorizations. So 216 is equal to 2 into 2 into 2 into 3 into 3 into 3. Now make 3 3's groups. So I put the underline here. You can get it very easily. Idea? Yes, student. Yes. So here you have to write only one time 2 and raised to 3. Multiply by 3 raised to 3. Is it or not? 3 groups will write one time only. As the prime factorization is appearing as many as times as a perfect multiple of 3. Therefore 216 is a perfect cube. Next one 128. 120 also divided with the same method. And we will get at last 2 into 2 into 2 into 2 into 2 into 2 and into 2. Here 2 pairs of multiplied 3 times 2 and 1 is alone. So that's why this is not a perfect cube. Next one, third one, 1000. Yes, my dear student, 1000 also same method. Now you are knowing how to divide it. Yes. Now look at the prime factorization of 1000. Yes. 1000 is equal to 2 into 2 into 2 multiplied by 5 into 5 into 5. Here, as each prime factor is appearing as many times as a perfect multiple of 3, therefore 1000 is a perfect cube. See the next question, fourth one, 100. So 100 we can check it. Yes, 2 into 2 into 5 into 5. There is no 3 pairs are there. 2 times and 5 2 times. No, any number is 3 times repeated. So triplets not possible. It's not a perfect cube. You have to write 3 times multiple means triplet. Remember the spelling. Triplets. See student, the triplet spelling is given here. Yes. Triangle. Yes, you are right, my dear student. Yes, correct. Triangle means 3 sides, 3 angles, like that. 3 things are that means triplet. Yes. Look at the 4, 6, 6, 5, 6. Yes, even number, we start with 2, then after 3. Yes, my dear student, correct. And look at the pairs. 2 times 3 triplets and 3 also 2 times triplets. So here we can say as many as time 3 multiple of 3's. It's a perfect cube. Look at the question number 2. Find the smallest number by which each of the following number must be multiplied to obtain a perfect cube. Which number we have to multiply? Then 243 we get new numbers and it's a perfect cube. So for that we should have to find out prime factorizations of 243. Yes, my dear student, 243 prime factorization. Now no need to do the here. Directly you can do answer 3 into 3 into 3 multiply by 3 into 3. See the students, here you can get a triplet of 1 time and second time only 2 numbers are there. Here 1 missing. If you multiply with 3, Now this pair will be completed. Triplet will be completed. So 243 multiplied by 3. Then after only it will become a perfect cube. Isn't it, students? Yes. So that's it. 729 is a perfect cube. Isn't it? Yes. Hence 243 multiplied by 3, which gives me a perfect cube. Same way 256. If 256 multiplied by 2, I will get 512, and 512 is also a perfect cube of 8. Yes? Correct. This is the perfect cube of 9. See, student, why it is said that 3 into 3 or 2 into 2 into 2 into 2 raised to 3 multiplied by 2 raised to 3 multiplied by 2 raised to 3. Isn't it? Or we can say whenever the exponents are same, we can take the base common and all multiplication in one time only only one time exponent we can take. Raised to 3 one time. So 2 into 2 4, 4 into 2 8. So 8 raised to 3 is the perfect cube of number 512. 8 into 8 64, 64 8 is of 512. Yes, my dear students, you can check through it. You will also get these types of confidence. Yes, my dear student, there is a 72. 72 prime factorization is 2 into 2 into 2. 3 times already over. 1 triplets become. But 3 into 3, only 2. Squares are there. 1 missing, 3 is missing. Yes, so multiply by 3, which gives me a 216. 216 is also a perfect cube. Isn't it easy? Same way, 675. 5 is missing. Multiply by 5, that gives me 3375. That is a perfect cube of 15. How I said 15? Because 3 into 5, 15. Correct. Triplets are there. So smallest number is 5. Here same way 400. Here 2 numbers are missing. Only 2. Because here triplet not become in both the number. So here if I can multiply with 2 and multiply with 5. Then and then only that 2 triplet will become and 5 triplet also will become. Yes, student? Correct? Very good, very good. So now look at here. The answer 2 times you have to multiply with 2 and 5. Yes, so 1000 will become. So tens are 5 twos are tens are 100 tens are 1000. So like that way you can also find. In square we learn whenever 2 zeros, 4 zeros, then it will become possible a square. So here in our cube minimum 3 zeros are needed. 2 zeros are not possible. So 3 zeros are possible to make a cube. Correct? Yes. So now look at the question number 3. Find the smallest number by which each of the following number must be divided to obtain a perfect cube. So 81 is there, 128, 135 and 192. Root and 704. Look at here, 81 prime factorization on your screen. Yes. So 3 into 3 into 3. Into 3. How I got this one? You had the doubt? Okay, see, I want to show you with the division method. 81 divided by like letter method. 3 are because it's an odd number. So here 3 2s are 6, 7s are, yes, my dear student, 27. Because we divide 81 by 3, 77. Or you can move here like this way. 27 multiplied by 3, which gives me a, yes, 81. Again 3. So 9 3s are 27. Very good, student. Again 3. 3 3s are 9. Yes, very good, student. Now again 3. 3 1s are 3. So it is easy. So 4 times 3 is there. How many numbers are missing here for tripleting? 2, 3 are missing. So 3 into 3, 9 you can multiply with 81. You will get a perfect cube. Or in our this question, they ask which number we can divide, then it will become a perfect cube. So who is the extra one? That should be here gone. 1 number or 2 number. Triplets is there as it is remain. So this 3 has to go. So this divided by 3. No need to take this one. So remove 3, or you can say divide by 3, 81 divided by 3, which gives me a, yes my dear student, 27. 3 3s are 9, 9 3s are 27. Then only it will become a perfect cube. Look at the next question, 128. Here also you have 1, 2 extra. So divide it with 2. Yes, 128 divided by 2, which gives me a 64. And 64 is a perfect cube. 1's cube 1, 2's cube 8, 3's cube are 27, 4 cubes are 64. Yes. 5's cube are 125. Correct. So like this way you should have to remember 1 to 20 squares and cubes. Yes, one more is here, 135. 135 having a 3 into 3 into 3 multiplied by 5. So 5 is extra here. So you can say divide with 5 gives me a 27. And just now in previous question we seen this thing. 27 is a perfect cube. Yes or no? Yes, correct. Now 192. 192 is equal to 2 into 2 into 2 multiplied by 2 into 2 into 2 multiplied by 3. So here you can find the triplets of 2 times 2's are there. So if we divide with 3, we will get 64, and 64 is a perfect cube. Correct, students? 704. Here 11 is extra. Divide with 11, 704. Divide by 11, which gives me a 64. Again it's a, yes, 704 divided by 11. You don't know. Okay, students, see 704 divided by 11. Where is the student? Why you have the confusion about this one? 11 1 ja 11, 11 2 ja 22, 11 3 ja 33, 11 6 ja, yes, very good, direct answer. Now your 11 table is so easy. 66, very good student. Subtract it. Yes, 70 minus 66, no need to borrowing or anything. You have to count from 66, 67, 68, 69 and 70. How many numbers are there, student? 4. So answer is here 04 of this subtraction. Bringing down this 4 down here. Yes, my dear student, this is 4 has to come down. Correct. So now 11 4s are 44. Yes, 44. And 44 minus 44, 0 0. Correct? Yes. So here you will get it. 704 divided by 11 is equal to 64, and 64 is a perfect cube. Yes, very nice, very nice. Question number 4. Parikshit makes a cuboid of plasticine of side 5 cm, 2 cm and 5 cm, height, width and breadth. How many such cuboids will be need to form a cube? Chote. I already taken in our introduction session. ऐसा like cube है बेटा. Look at here. 5 cm, 2 cm and 5 cm. Correct? So now, what is the LCM of 5 to 5? It's a 10. Okay, let us try to make a cube of 10 cm. For arrangement, we have to put 2 cuboids along with the length, 5 along with its width and 2 along with its height. Or we can say 2 into 5 into 2. That gives me a 20. Yes or no? 5 2s are 10, 5 2s are 10, 5 2s are 10. Height, width and broad. Always 10, 10, 10 are needed. So now this is the perfect cubes. बाजू में 2 और ऊपर 1. ऐसे जाएंगे तो 5. Correct? Yes. See, here 1 cube was there. Okay, second one is here and 2 more are there. 3 cubes are there. And here you can add 5 more cubes. Clear? Yes, 1, 2, 3, 4, 5. Isn't it? Correct. Okay, alternatively you can find the volume of the cube is 5 to 5, 5 into 2 into 5. 5 is a 25, 5 to 2, 50. 50 centimeter cube. Now, 2 5s and 1 2. What things are missing? 1 5 and 2 times 2. So you can multiply 5 into 5 into 5. One triplet become 2 into 2 into 2. Second triplet also become what you add 1 times 5 and 2 times 2. That gives me 1000. Yes, it's a perfect cube. So any method you can use, either a drawing wala or volume wala. Volume is easy. Now students, there is a question number 1 of exercise 7.2. See, our daily life also, it is also useful, cube and squares. So don't think these squares and cubes are not necessary to develop our daily life. See, suppose you want to construct anything, house, shop, apartment, bridge. So it's need a 3 dimensions. How many bricks are needed? What is the height of the wall? What is the height of the shop? So that you should have to calculate, and according to that you can construct. Otherwise it is not possible. See, find the cube root of each of the following numbers by prime factorization method. So many are given. So here tens are given. Just the question tens. Let's we start from first 64. Prime factorization of 64. Yes, you are knowing very well what you have to do. In rough side, you can do it 64. Yes, my dear students, so many numbers will come. That's why I want to show you method 2. Divide by 2, that means a 32 will come. Again divide by 2, this gives me a 16. Again divide by 2, that gives me a 8, etc. down. So you have the 2 times triplets of 2. So 2 into 2, 4. Answer is 4. Square root of 60, cube root. Square root, no. Cube root of 64 is a 4. 4 for the 16, 16 for the 64. Prime factorization 512, 2 into 2 into 2, that gives me 8. Triplets you have to make. In square we did 2 2s. Here pair of 2, here pair of 3. 3 का pair बनाना है. Okay? Correct. 10,648. It is also a 22s. Correct. Prime factorization of 27,000. Yes, I just said before, here for checking the perfect cube, if 2 zeros are there, they are not a perfect cube root. 3 zeros, then only you can try it. Yes, 2 into 3 into 5. 5 to the 15 to the 230 is the answer. 6 is a 9, 9 is a 27. And 3 zeros are there. Easy? Yes. 15,625. Which is also a cube root of 20. 15,625 cube root is 25. 13,824. Students, here it is also a perfect cube roots. Perfect cube roots of 13,824 is 24. So method you can just see it and find out the answer. 7, yes. 8, yes. 9, yes. But big numbers, don't be confused. Here prime factorization method, you can find only prime numbers, nothing else. Yes, my dear student, fraction of 91,125. Last question of this one. You can just try out. 2 is not possible because this is a odd number. How to find odd numbers? Once again I remind you, last number you have to check. If last number is 2, 4, 6, 8 or 0, then it is a even. Otherwise, you see a 1, 3, 5, 7 or 9, it's a odd number. Clear? Correct. Now look at here, question number 2. State true or false. Yes, your favorite questions, my dear students. You are very happy to see these types of question in exam or anywhere. You just have to do choice, true or false. Cube of any odd number is even. Oh, very good question. Cube of any odd number is even. 125 का क्यूब क्या होता है बेटा? 5 का क्यूब क्या होता है? 2 ऑड नंबर. 5 5 है 25, 5 25 तो 125. Even number है 125? No, odd number. So first answer should be false. For finding the cube of any number, the number is first multiplied with itself and this product is again multiplied with this number. पहला है false. When we find out the cube of an odd number, we will find an odd number as the result because the unit place digit of an odd number is odd and we are multiplying three odd numbers. Therefore, the product will be again an odd number. Yes, the example is given 3. 3 into 3 into 3. 3 is 9. 9 is yes, 27. And 27 again a prime, sorry, odd number. Correct? Second one. 2. The perfect cube will end with a certain number of zeros that are always a perfect multiple of 3. 10. I just said 3 zeros are needed for perfect cube. 10 into 10, 100, 100 into 10, 1000. 3 zeros at end. The cube of 100 is 6 zeros. 1 cube 1 and 100 means 2 zero. So 2 to का 3 time pair बना दो. 2 to 4, 4 to 8. Correct here? How many zeros are there? 6 zeros are there. So 3, 6, 9 zeros are minimum needed for any perfect cubic. Oh, perfect cubic means before zeros, the number should be 1, 8, 27, 64, 125, etc. Correct. False. If it is not always necessary that if the square of a number end with 5, then its cube will be end with 25. Not it, non it, compulsory नहीं है बेटा. जैसे कि बोलते 25 का क्यूब क्या रहेगा? 25, 5 का एग्जाम्पल है, 5 का स्क्वायर है 25 है और उसका क्यूब है 625. 625 has its unit digit is 5. The cube of 25, yes, is 15,625. The square of 35 is, yes, 1225 and also has its unit place digit is 5, but the cube of 35 is, yes, 42,875. ऐसा हर बार जरूरी नहीं है. हाँ, स्क्वायर में जरूरी है. 5 जिसका यूनिट डिजिट है उसका लास्ट स्क्वायर रहेगा वो 25 रहेगा, बट क्यूब रहेगा नहीं, अलग अलग रहेगा. 75 भी रह सकता है, 25 भी रह सकता है. नेक्स्ट क्वेश्चन. False. There are many cubes which will end with 8. The cubes of all the numbers having their unit place digit as 2 will end with 8. 12 का है 8 वाला, 22 का है 8 वाला. बराबर बेटा? जिसका भी यूनिट डिजिट 2 है उसका क्यूब 8 वाला ही रहेगा. मैजिक है. I already shown in our introduction sessions. You just see that video. Fifth one also wrong. The smallest 2 digit natural number is 10 and the cube of 10 is 1000, which has 4 digit in it. Correct? Yes. 6th one also false. The largest 2 digit number is 99 and cube of 99 is a 97. 0 to 99, that means 9,70,299, which has 6 digit in it. Is clear beta? The cube of any 2 digit number cannot have 7 or more digit in it. 6 digits हो सकता है, 6 से नहीं होगा. Last वाला 7th one is a true one, as the cube of 1 and 2 are 1 and 8 respectively. Correct? Question number 3. You have told that 1331 is a perfect cube. Can you guess without factorization what is its cube root? Similarly, guess the cube roots of 4,913, 12,167 and 32,716. Yes, why not? First of all, we can check it a group of 3 numbers, 3 digits. Yes, so 331 and 1 alone. Rightmost digit is 331. There are 2 groups. 1 and 331 in it. Considering 331, the digit as its unit place is 1. We know that if the digit 1 is at the end of a perfect cube number, then its cube root will have its unit place digit as 1 only. Therefore, taking the other group 1. The cube of 1 exactly matches with the number of the second group. Therefore, the 10th digit of our cube root will be taken as the unit place of the smaller number whose cube is near to the number of the second group, that means 1 itself. 1 will be taken as 10th place of the cube root of 1331. So 11s. This is the symbol of cube roots. Yes, my dear student, you can know very well how to read out this one. Cube root of 1331 is 11. This is the sign of cube root. Yes, my dear student, don't forget. And inside there is a numbers. Okay, any number. And only this sign will give a, yes, my dear student, this is a square root. Correct. Very good. So it's calculated like this way. Second one, you are having here, last digit is 3, last digit is 3, then its cube root is at the end of perfect cube. Yes, its cube root will have its unit place is 7. Therefore, the unit place digit is 7. Now, what is left on this side? 4. Yes, we know that 1's cube is 1 and 2's cube is 3. Sorry, 2's cube is 8. So, 4 is below or smaller than 8. That's why we have to take 1. A smaller number we have to take. Smaller cube is we are taking 1. Yes. So, 1 and 7 is a guessing, not perfect, student. No, beta? Guess. Just check out. The cube root of 17 has to be calculated like this way. Next number 12,167. Here two groups are there of 3 digits. Yes, my dear students. Again, last digit is 7. If last digit is 7, then perfect cubes we will make it 3. Unit digit is 3. Yes, my dear students. Now 12 is remaining. 12 is lying between 1, 8 or 27. Yes, 2 cube is 8 and 3 cube is 27. So 8, 27 and in middle 12 is lying. So we can take smaller cubes of 2. So 2 and 7 is the answer, 27. Yes, my dear students, look at other one. 23. Because 7 is there, 3 is there and 12 is 2. Look at the year 32,768, my dear student. 768, last digit is 8. That means it's end with a perfect cube number. Then its cube root will have its unit place digit as 2. How to remember Ande ka funda? Yes, 8 है तो 2, 7 है तो 3. Clear? Correct. Therefore, the unit place digit of the required cube root will be taken as 2. Now, who is left? 32. Again, 3 3s are 9, 9 3s are 27, and 4 4s are 16, 16 4s are 64. So, 64 is larger than 32 and 27 is smaller than 32. So, we can take 27 wala. 27 means 3 cubes. So, here we can take 3 and 2 is our approximate answer. Yes, my dear student, here we can complete our exercise 7.2 and chapter also. I think so, there is no doubt for anyone. So, it's a time to say thank you and bye-bye. Take care and be safe. Bye-bye.